In this section, we're going to talk about rational exponents. Let's remember what we just did in the last section. Remember we had a to the n was equal to b, and therefore a was going to equal the nth root of b. Well, now let's take an example here. Let's say that, well, first of all, remember that x to the m taken to the nth power. So we're taking an exponent of an exponent. What do you do with the exponents? We multiply them. So m times n becomes the new exponent. So what if I had this? What if I had x to the 1 over n all to the nth power? Well, that's going to equal, you multiply the exponents, that's going to equal n times 1 over n. And that's n is n over 1. So what's n over 1 times 1 over n? Well, these cancel, and I'm left with x to the 1, which is just x. So what that means is that x to the 1 over n to the nth power is equal to x. But remember up here, I had this exponent here. To get rid of it, I move it over here and make it an nth root. So if I want to get rid of this exponent here, I'm going to move it over to this side and make it an nth root. So I end up with 1, or x to the 1 over n is equal to the nth root of x. So look at that now. So now we've figured out a way to express the nth root of a number as an exponential form. And all you do is take whatever that nth root is, and it's 1 over n. So x to the 1 over n is equal to the nth root of x. And so 16 to the 1/2 would be square root of 16, which is 4. So let's try some other definitions here. So let's take a formal definition of an exponent or a rational exponent. So we have x to the m over n is going to equal the nth root of x to the m. Now, where does that come from? Well, let's see. We have x to the m over n. Well, that's x to the m times 1 over n. Because that's m over 1. When I multiply straight across, I get m over n. Well, since I'm multiplying exponents, I could say that's also x to the m all to the 1/n or 1 over n power. And since 1 over n means a root, that becomes the nth root of x to the m. So now let's look at the different properties of exponents that you recall all these properties for exponents. So we have a common base with two different exponents. We add the exponents. So if it's let me give you an example. If it's x to the 1/2 times x to the 1/2, that's going to equal x to the 1/2 plus 1/2, which is x to the 1, which is equal to x. In this case, we have x to the 7/2. Let's try that again. X to the 7/2 divided by x to the 3/2. So since we're dividing, this says that we subtract exponents. So that's going to be x to the 7/2 minus 3/2. So 7/2 minus 3/2 is 4/2. And 4/2 is equal to 2, so this becomes x squared. The power, take an exponent of an exponent. If we have x to the 3/4, all taken to the 8th power, that's going to equal x to the 3/4 times 8, and that's 8 over 1. So we can cancel that 4 cancels here, leaves a 2. That's going to equal x to the 6th. Then the power of a product. So now we have exponents inside of parentheses. We take all of that to the 1/6 power, and then we basically distribute that 1/6 into each of those exponents. So x to the 2 times 1/6 and y to the 3 times 1/6. And that's going to equal x to the 1/3, because 2/6 is 1/3. One third times y to the 3/6, which is 1/2. Now the power of quotient, so I have, as an example, z cubed all over 25. All that to the 1/2 power. So that 1/2 goes into both of these exponents. This becomes z cubed over 5 squared to the 1/2. Now that 1/2 goes in, and 3 times 1/2 all over 5 squared times 1/2. And this becomes z to the 3/2 all over 2/2, or 2 times 1/2 is 1, it's just over 5. And so we get, that's equal to 1/5 z to the 3/2. The 0 exponent, just like anything else, any number to the 0th power is 1. And the negative exponent, so 25 to the minus 1/2, the minus exponent just means reciprocal. So that's going to be 1 over 25 to the 1/2. That's equal to 1 over 5 squared to the 1/2, which is 1 over 5 to the 2 times 1/2, which is 1 over 5 to the 1, which is 1/5. So that's how each one of those different properties for exponents applies when you have rational exponents. Let's try some examples. Okay, first one is A, 16 to the 1/4. That's equal to the 4th root of 16, which is going to be 2. B is minus 125 to the 1/3 power. That negative sign is not taken to the 1/3 power. If you wanted that negative to be included, it would have to be put in parentheses with the 125. So the negative remains there out front. So it's minus 5 cubed to the 1/3, which is just minus 5. And then C is minus 9. Now that is in parentheses to the 1/2. So the minus sign is taken to the 1/2 power. That's just the square root of minus 9, which is going to be 3i, imaginary number. Let's try example 2. So evaluate 4 to the 3/2. Well, that's going to be 4 cubed all to the 1/2 power, which is the square root of 4 cubed, which is the square root of 64, which is equal to 8. Now we could have done that the other way. We could have said 4 to the 3/2 is 4 to the 1/2 cubed. That would still give me 4 to the 3/2. And that's equal to square root of 4 all cubed. Square root of 4 is 2 cubed is equal to 8. So in both cases, you get the same number. Both ways are correct. Next example. Now I'm going to convert these, the first one to exponential form. So we have the 4th root of 75 a cubed b. Well, that's going to equal 75, a cubed, b, all to the 1/4 power. And 75 is going to be 25 times 3, which is 5 squared times 3 times a cubed times b, all to the 1/4 power. And so now we bring that 1/4 into every one of those exponents. That's going to be 3 to the 1/4 times 5 to the 2/4 times a to the 3/4 times b to the 1/4. And then simplifying that further, 3 to the 1/4, 5 to the 1/2, a to the 3 to the 3, let me try one more time, 3/4, b to the 1/4. And that's the answer. The next one, b, this is a. So now we're going to convert 2 to the 3/5, x to the 4/5, and y to the 1/2 to a radical form. So in that case, we need this denominator to be the same, so the common denominator is 10. So this becomes 2 to the 6 tenths, x to the 8 tenths, and y to the 5 tenths. And so that becomes 2 to the 6th, x to the 8th, y to the 5th, all to the 1/10 power. And so this becomes 64, x to the 8th, y to the 5th, the 10th root of that. And there is now that exponent, or that expression given to you in exponent form is now given in radical form. All right, next example, 4. So we have a is 36, a to the 6th, b to the 12th, all to the 1.5 power. So now we have a decimal for an exponent. Well, that can just be rewritten as 36, a to the 6th, b 12 to the 3/2. 1 and 1.5 is 3/2. So now we bring that 3/2 in. It's 36 to the 3/2 times a 6 times 3/2 times b to the 12 times 3/2. And this becomes 36 to the 1/2 cubed. Now this 2 cancels with that 6 and leaves a 3. So this becomes a to the 9th. And again, because that's odd, we want to guarantee that we have the principal root. So we're going to put the absolute value signs around that. And then 2 cancels here with the 12 and leaves 6. And 6 times 3 then is 18. So 36 to the 1/2 is the square root of 36 to the 3rd power, a to the 9th in absolute value, b to the 18th, and the square root of 36 is 6. So it becomes 6 cubed, which is 216, a to the 9th, b to the 18th. The second one, b, we've got 216, x to the 9th, all over 125. And that whole thing is taken to the 1/3 power. And so we bring that 1/3 in. 216 we know is 6 cubed times 1/3, x to the 9th times 1/3, all over 125, which is 5 cubed times 1/3. That's going to equal 3 times 1/3 is 1, so that's just 6 to the 1. X, cancel the 1, 3 goes in 3 one time, 3 goes in 9 3 times. It's going to be x cubed. And 3 times 1/3 is 1, so it's going to be 5. So it's going to equal 6/5 x cubed. Next example. Example 5. Simplify each radical expression. So we have the fourth power of 1024. Well, if you know your powers of 2, 1024 is 2 to the 10th. You can find that out by building a factor tree. And so that's simply 2 to the 10 over 4, which is equal to 2 to the 5 halves, which is equal to 2 to the 2 plus 1 half. So again, if I'm adding exponents, that's the same thing as 2 to the 2 power times 2 to the 1 half power, which is equal to 4 square root of 2. And that's the answer. That's how you simplify that. For B, we have the square root of 8 all over the cube root of 4. And so this is going to be the square root of 2 cubed all over the cube root of 2 squared. So that's going to equal 2 to the 3 halves, because 1 half is the square root and 3 is the power, divided by 2 to the 2 thirds. And since we're dividing, I have a common base, I just subtract the exponents. So that's equal to 2 to the 3 halves minus 2 thirds. Common denominator in the exponents is 6, so that's going to be 9 sixths all over 4 sixths. And that's going to equal 2 to the 5 sixths, which is going to equal the 6th root of 2 to the 5, which is the 6th root of 32. And the last example, there's an equation at the beginning of the section on how to figure out interest. And it says that the actual amount, the amount that you have in your bank account, is the principal times 1 plus the interest rate, all to the power time. So what does that mean? That means if you have a certain amount of money that you're going to invest, this is the principal. Let's say you're going to invest $1,000. That's how much money you want to put in. So however much money you put in, that's the principal. The rate is how much a bank or an investment is going to pay you every period, every year. Let's say it's 3%. And then the amount of time is how long you keep it. This is 3% per year. And T is going to be the number of years. And so let's look at an example. It says use that formula to find the account balance if $10,000 is invested for 2.5 years with an interest compounded annually at 5%. So in this case, our principal is equal to 10,000. Our rate is equal to 5%. And the time is going to be 2.5 years. And so the actual amount that we have is going to be 10,000 times 1 plus decimal. We got to put 5% into decimal, which is 0.05, all to the 2.5 power. And so that's going to equal 10,000 times 1.05 to the 2.5. And we go to a calculator to figure that out. And we're going to have 10,000 times 1.05 to the 2.5. And so it means we're going to have 11,297. So that's going to equal $11,297.26. So that means if you have $10,000 that you're going to invest in a bank and they're going to give you 5% interest per year, and you keep that $10,000 in the bank for 2.5 years, you'll end up with $11,297.26. All right, so that's the section on rational exponents. Go back and make sure that you understand the definition, how to use rational exponents, where they come from, and then work through each example, including all those properties for exponents, how it applies when they're rational exponents, and work through the examples, and we'll bring one question into class, at least one question that we can talk about, and then we'll work on some problems in class. Thanks.